All right, guys, so we just finished talking about all the properties of parallel lines. Now we're going to talk about what that looks like in the coordinate plane. So these should be things that you hopefully remember from algebra, talking about slope formula, slope-intercept form, point slope formula, those types of things. So to start with, we're going to talk about how to find slope, and we're going to define it here. So looking at this, remember we define slope by looking at it from left to right. What is it doing? So from left to right, we see that this is going up, so that's a positive slope. When it gets to the top, that's flatlined, that's a zero slope. If you remember from slope due, it's puff, puff, positive. This is zero fun. He goes down the slope, nice, negative. And when he falls off the cliff, the curse word of algebra, undefined. A vertical slope is undefined. So feel free, obviously, to pause this as you need to write down these notes. Okay, now I just went ahead and drew two lines here. Now, for this, these are two special cases. Again, if it's a vertical line, when I look at this, that's the 0.24 there. If I was to plot that point, this is the 0.22, that's the 0.20. That's the 0.2, negative 2. That's 0.2, negative 4. What do they all have in common? X equals 2. So this is the equation. That's the graph of the equation, x equals 2, or function we can call it. So x equals 2, that's the line represented by that. Now for this one, it's a horizontal line. And again, if I plot those points, look at this. 3, negative 3, negative 3, 0, negative 3, 4, negative 3. Again, what do they all have in common? Y equals negative 3. I just picked those random points. You could pick any of those dots and plot them. But all the points along that line, what's always the same? That y is negative 3. So the function, the equation for that line, we could say is y equals negative 3. All right, finding slope of a line. And we're given 2 points here. So again, this is 3, 5, and 3, 6 stuff. So this is going to be all kind of thrown together here. So for this, if I'm given 2 points and I just pick 2 random points, negative 3, 8, 5, negative 2. When you label them, remember the first value is always x. The second is y. So we're going to call this x1 and y1. And if those are the ones, we'll call these 2's x2 and y2. Now from there, my slope is y2 minus y1 all over x2 minus x1. We call that rise over run. So if I'm going to find the slope of that line given 2 points, now this is what you're going to have to do on your 3-5 homework. You're going to be given 2 points, and you're going to be doing it like this or on the graph or both. Here's how you find the slope. I just plug those values in. Wherever I see y2, I replace it with negative 2. Where I see y1, I replace it with 8. Where I see x2, I replace it with 5. Where I see x1, I replace it with negative 3. And notice I have minus a negative 3 there. So that's going to become positive. It's going to become 5 plus 3. So when I simplify that, it becomes negative 10 over 8, which then becomes negative 5/4. Always remember to simplify. Now, if you're given a graph, which is what your homework's going to look like, let's go ahead and plot 2 points here. Now, Mr. R, how'd you pick this one? Well, I'm just picking wherever I see the green, where the green boxes, where the green lines form, where the line crosses them in the middle of them. Okay, so where I see the black line cross where the green lines intersect, that's a point. So this is a point, -2, 3. Now I could have picked multiple other ones, but -2, 3 was the simplest one. And as well as 4, -4. Now on your homework, it'll already have those plotted for you. And again, I already defined it as x1, y1, x2, y2. And then I can do the same thing. However, if you're given the points, if you're given the graph, you can also do it this way. Remember, it's rise over run. So I can just count these. 1, 2, 3, 4, 5, 6, 7. I had to go down 7 to get from that point. And I go right 1, 2, 3, 4, 5, 6. So I went down 7, right 6. Remember, it's rise over run. So my slope is just -7/6. Or I can use my slope formula, and I can just plug those in again. Wherever I see y2, I replace with -4. Where I see y1, I replace with 3. x2 is 4. x1 is -2. And when I simplify that, notice I get the exact same thing. So you can use either method. Now go ahead and write this down. Here's for the second part of your homework on 3.5. Parallel slopes. Parallel slopes have the same slope. If the slopes of two equations, of two functions are the same, those functions are going to be, the graphs of those functions are going to be parallel. Those lines are going to be parallel. Examples. 2/3 and 2/3. Those are the exact same. Or -3/7 and -3/7. 3 and 3, whichever. If the slopes are the exact same, have to be the exact same. 3 and -3 are not the exact same. 3 and 3 is. If they are the exact same, they are parallel. In order to be perpendicular, those are opposite reciprocals. So an example of that means you change the sign from positive to negative. If it's negative, it goes positive. If it's positive, it becomes negative. And you flip the fraction. So for example, -3/5 and positive 5/3. Notice that 3 and 5 flipped and it went from negative to positive. If you see two slopes whose slopes are -3/5 and positive 5/3, that would indicate that they are perpendicular. Or 7/4 and -4/7. Positive 7/4, positive 7/4, -4/7. Now this one looks a little weird. Remember, that would be 3/1. So 3/1 and -1/3. Those are perpendicular slopes. 0 and undefined. Remember, 0 is horizontal, undefined is vertical. Those would also be perpendicular slopes. Now your homework, it's going to give you 4 points. So it's going to give you 2 points for one line and 2 points for the other. Your job is to find the slopes of both. If you see that the slopes are the exact same, you know that they are parallel. If the slopes are opposite reciprocals, you know they're perpendicular. And if the slopes end up being neither of these, they are not the exact same, and they're not opposite reciprocals, then they are neither parallel nor perpendicular. That's it. So an example of this, and this is what it would look like graphically, but you can do this without a graph. You can do it with just points. In fact, I'll illustrate that here. If I just pick points here. So there's my red line. I'll call my red line and my green line. And I'll just pick random points on here. So for my green line, if I want to find the slope of, on that green line, where I've put my points 7 and 4, 5 and -4. Again, on your homework, it'll just give you points. It won't even give you a graph, but that's all you need. We're going to find the slope of the green line using the 2 points they gave us. So I go 4 minus -4, and 7 minus 5. Simplify that, and it becomes 4, or 4 over 1. Now for my red line, it's 2 minus 0, and negative 2 minus 6. Now you can ask yourself, well, Mr. R, how do you decide that it's 2 minus 0? What if I did 0 minus 2? You'd still get the exact same thing. You could go 0 minus 2 all over 6 minus negative 2, and you'll still end up with negative 1/4. Now remember, that's for green, that's 4 over 1. And for red, it's negative 1 over 4. Those are opposite reciprocals. Therefore, these are perpendicular. Which they look like they're perpendicular. That looks like a 90-degree angle. So that works. Okay, so that's how you do 3-5. That's all the information you need to know on how to do 3-5. Now moving on to 3-6, equations of a line, slope-intercept form, and point-slope form. These are going to be the two that we use a bunch. So if you're given a slope and you're given a y-intercept, you put it in slope-intercept form. Nothing crazy there. So for example, I go y equals, now I just plug the stuff in. Y equals m, that's my slope, x plus b, my y-intercept. So y equals mx plus b is my slope-intercept form. And whatever I'm given for m, I plug in for the m. Whatever I'm given for y-intercept, b, I plug in for b. Point-slope formula, if I'm given a point and I'm giving a slope, I use point-slope formula. That's why it's called point-slope formula, is because I use a point and a slope. If you're given 2 points in a slope, you can pick either point, it doesn't matter. So for this case, plug these in, I go y minus, I plug in my x1, plug in my y1, and plug in my m. So it's y minus y1 equals m, x minus x1. Notice the black y and the black x. Those I'm not plugging anything into. So don't get confused and plug in something for that first y or something for that first x. Those stay the same. Those stay as y and x. They don't change. The things you plug into are x1 and y1 and my slope m. I do not plug in, if there's a second point, I don't plug in my second x for the black x. I don't plug in my second y for the black y. I go y minus y1 equals m, x minus x1, using 1 point. And I'll give you some examples of what that looks like. So here, I'm given a slope and a y-intercept. If I'm given slope and y-intercept, I use slope-intercept form. And here's the example I just came up with. A slope of 3 and a y-intercept of negative 2. Cool. So I just plug in. Remember, that's y equals mx plus b. Wherever I see m, I replace it with 3. Wherever I see b, I replace it with negative 2. And I get y equals 3x minus 2. That's it. Those are the easiest ones to do. Again, hopefully this is familiar from algebra. Now this one, if I'm given a slope and a point, I'm using point-slope form. So y minus my y1, 6, equals my slope, 2/3, x minus negative 3, minus a negative. Remember, my minus stays there, and I got to include the negative because my x1 is negative 3. And now I just simplify. Y minus 6 equals, I distribute 2/3 x and 2/3 times 3 times a positive 3 is positive 2. And then I got to subtract my 6, or add my 6 to both sides. So I get y equals 2/3 x plus 8. Always get y by itself, because now I have it in slope-intercept form. My slope is 2/3, my y-intercept is 8. If you're given 2 points, What is the only thing you can find if you're given 2 points? Slope. If I can find the slope of that line, now I have a slope and I have a point, so I can put it into point-slope form. So here's what that looks like. First, I find my slope, which in this case is -2. And then from there, I can use the point -2, 3 or the point -3, 5. It doesn't matter. Just pick one. Don't use both. I pick one. Pick 1 point. So I went with y minus 3 equals -2, my slope, x minus -2. I went with the first point. So y minus 3 equals -2, and then all that. Go ahead and distribute the -2. -2 times +2 would be -4. And I'm going to add 3 to both sides to get y equals -2x minus 1. So again, if I'm given 2 points, the only thing I can find with 2 points is a slope. From that slope, I pick a point and put it in point slope, and then I have slope-intercept form. If you're given a picture of a line, well, from this picture, I can find slope and I can find the y-intercept. Remember, y-intercept is where it crosses the y-axis. I see here it crosses at -3. And I can count my slope or I can find it, either way. In this case, I see that my slope is 3. If I go from the point 1, 0, and I count up 1, 2, 3, over right 1, I get to that next point. So I see my slope is 3, my y-intercept is -3, so I just plug into slope-intercept form. Now here's where it gets a little trickier. It says, write an equation parallel to the given line, in slope-intercept form. Now, what's the slope of this line? Well, it's in slope-intercept form, so my slope is -2/3. Now, what do we know about parallel slopes? They are the exact same. So, I already know that my slope for the equation I'm writing is going to be also -2/3, and it goes through the point -4/7. So I have a point and I have a slope. So I use point-slope form. Y minus 7 equals my slope -2/3, x minus -4. Simplify that. And there we go. Now, my y-intercept I left as an improper fraction. You can turn that into a decimal if you wish. That'd be 4 1/3. And so when I graph that, remember whenever we graph, we always start with our y-intercept. So my y-intercept is going to be at the point 4 1/3, right around there. And then it says my slope tells me to go down to right 3. So I can go up to left 3 or down to right 3, either way. And then connect my line. That's the graph of that equation. Okay, this one says write an equation parallel to the given line. Now, in this case, I have to find my slope because it's not given. I need to put it in a form that allows me to find the slope. So that means I'm going to have to solve for y, so that I get it in y equals mx plus b, or slope-intercept form. So I subtract 2x from both sides, and I'm going to divide everything by 6. So I get y equals -1/3 x plus 3. That tells me that my slope is -1/3. And it says parallel, so the slope of the line I'm going to be writing is also going to be -1/3. And I'm given the point for -5. So I have a point and I have a slope. I'm going to need to put this in point-slope form. So y minus -5 equals -1/3 x minus 4. Using that point and using the slope of the line that's parallel to the slope of -1/3. And again, parallel slopes are the exact same, so I use just -1/3. Plug that in, distribute, and it's y plus 5, so I got to subtract 5 from both sides, and I get y equals -1/3 x minus 11 thirds. So again, that's 2 2/3. So I come over here, my y-intercept is -2, or sorry, -3 2/3, sorry. -3 2/3, so I mark that. And then my slope tells me to go down 1, right 3. Down and right 3. And I can connect the line there. Okay. This one says write an equation perpendicular to the given line in slope-intercept form. So if this slope of this line is 3/5, the slope of the line perpendicular to it is -5/3. And it says it goes through the point -4, 2. So again, I'm given a point, and I already now know my slope, so I put it in point slope form. So I go y minus 2 equals my slope, which again is perpendicular. So instead of 3/5, it's negative. Instead of positive 3/5, it's -5/3. Y minus 2 equals -5/3 x, parentheses x minus -4, close parenthesis. I'm going to do the same stuff. I'm going to distribute. I'm going to add 2 to both sides. So I get y equals -5/3 x minus 14/3. So again, that's going to be -4 2/3. So I mark that, -4 2/3. My slope tells me to go down 5, right 3. Well, I'm going to run out of space if I go down 5, right 3. So I'm just going to go up 5, left 3. If I go up 5, left 3, that's my next point. And then I've got my graph. Connect the dots. Last one says write equation perpendicular to this. So again, I don't have it in a form that allows me to put it, in which I already know the slope of the line. So I need to put it in a form that allows me to find the slope. So I'm going to get y by itself and find the slope that way, putting it in slope-intercept form. So I go 7y equals -4x plus 2, because I subtract 4x from both sides. And then I'm going to go y equals -4/7 x plus 12 after I divide everything by 7. No, this should be should be 12/7. But anyways, from there, go ahead and graph that. So 12/7 or 1 5/7. So 1 5/7 is going to be somewhere around here. And then it says my slope tells me to go down 4, right 7. So I go down 1 2 3 4, or I can go up 4. 1 2 3 4, left 7. 1 2. Right around there. I'm going to connect my dots there. I'll get the graph of my line. So those are all the different scenarios for when graphing lines. I can be given a slope and intercept. I can be given a slope and a point. I can be given 2 points. I can be given a picture. Or in cases where it asks me to write an equation of a line that's parallel or perpendicular to it. If it's already in slope-intercept form, I already know the slope. I can just plug it in to point slope form right away. But if it's not in slope-intercept form, I just need to solve for y, and then I can find the slope from there. And then once I have the slope, then I can find the slope that's either parallel or perpendicular to it. Remember, parallel slopes are the exact same. Perpendicular slopes are just opposite reciprocals. And that is all the information you need for doing 3-5 and 3-6. Remember, so 3-5 is everything here. into, yeah, up into this point. Remember, in order to do the second part, the first part of 3-5, in order to do the first part of 3-5, you're just finding slope. And you can use either one of these methods. You can use the points and find the slope just using the formula, or you can count and use rise over run to find slope. And to determine if it's parallel perpendicular, remember, if it's parallel, it means the slopes are the exact same. If it's perpendicular, it means they are opposite reciprocals. Flip the fraction and make it the opposite sign, positive, negative. And we did that here. Given points, 2 different points on 2 lines, we found the slope of each line, and then we saw, in this case, they were opposite reciprocals, so they're perpendicular. If they were the exact same, we'd say they're parallel, and if they were neither of those, we would say neither. And lastly, for doing 3-6, those are the 2 formulas you're going to use, and those are all the cases. Hope this helps. Thanks, guys.